Take a moment to pause this video to read the problem setup, and also read this information about the normal approximation to the binomial probability distribution. Specifically here, to find these different parts, we're asked to use the normal approximation. So in order to do so, the first thing we need to do is verify that NP times 1 minus P is at least 10, or greater than or equal to 10, where N is the number of trials and P is the probability of success. So here N is this value, the 152. And P is this value, written as a decimal, of course, 0.82. So let's first verify that N times P times 1 minus P is at least 10. So I'm going to do that here in my calculator. N being 152 times P being 0.82 times 1 minus 0.82. And yes, we see that that is greater than or equal to 10. So now that means that we can proceed with the normal approximation. So the next thing we want to do is find the mean. The mean is defined as N times P. So N times P. This is the mean, 124.64. And the standard deviation is the square root of NP times 1 minus P. But notice that's the same thing that we just had to do as the condition to use this normal approximation. So we're going to take the square root of either this or this. I mean, it really doesn't matter which one you choose, I guess. And that is the standard deviation. So let's make note of those two values. Okay, so next we're going to turn back to our calculator here in a second and use the normal cumulative probability distribution function. But one of the things I want you to think back to, if you think back about your notes on section 7.4, we are using a continuous function to approximate a discrete binomial probability. So to account for this correction for continuity, we will both add and subtract 0.5 from 112. Now specifically I'm doing 112 because that's this first part. Find the probability of exactly 112 flights on our own time. And then I'm going to use that information in my calculator. So let me write that out. So in a mathematical notation, this is what I'm trying to say. Now, I've also put this note here. Refer to table 5 in section 7.4 because this is a really good table that gives both the exact probability using the binomial, the approximate using the normal, and a graphical depiction. So that's a really good table to reference as you do problems like these. Okay, so now let's look at our calculator. All right, so let me just move this over here just a little bit. Okay, so we're going to do second distribution and the normal CDF. Our lower bound is 111.5. Our upper bound is 112.5. Our mean we calculated earlier using the formula. And the same thing with our standard deviation. We calculated that earlier. If you're finding that your answers are not, like they're close to what my math lab says, but not exact, it could be that you need some more accuracy here, or it may have been that you did not account for the correction for continuity. Okay, and then we get the following value. And we're asked, I think in this problem, round that to 4 places. So 0.0024 is what we see right there. Just really quick, I'm going to show part B of this problem. If you find you need part C or D, just email me and let me know. But in part B, again, I'm going to refer back to the table. I'm asked to find the probability that X is greater than or equal to 112. or in other words, that at least 112 flights are on time. So graphically speaking, that approximation that to the normal distribution, that is going to look like this. It needs to, in other words, capture the 112. So I actually need to back up 0.5 or do like this. I need to find probability of x greater than or equal to 111.5. So let me write that down for part B. So now that helps me whenever I go to do the normal CDF here in my calculator. My lower bound is 111.5. I guess I did not need to retype that. Upper, just to go up to the maximum value, I could put 1E99 just to be safe. Same mean, same standard deviation. And that's how we end up with 0.9972, just as the answer has here in my MATLAB.